arrived at his house at 2:10 p.m. Bill's mother told her the direction in which Bill went, and Mary cycled after him at a speed of 16 miles per hour. At what time did Mary catch up with Bill? All right. Where would we begin? Table. What formula is going across the top? Okay, what would my rows be? Yeah, but my columns are. All I have are the two people. It's not like the mixture problems we were mixing two things and getting a total. Here we just have two people. All right, so now we go back in. We know how fast did Bill go? Okay, so that's his rate. What about Mary? All right, time. How long did Bill ride? 10 minutes. Did he stop at the end of 10 minutes? No, he kept going. Okay, one of these has to be our variable. We can do it either way. So pick one. Who do you want to be our variable? Bill or Mary? Mary? Okay. So did Bill have more or less time than her? More. So plus. Okay, but if I put x plus 10, that's actually wrong. Can you guys figure out why?
Or no, it's in hours.
Okay. My rate is miles per hour. That means time has to be in hours. 10 is in minutes. How would I change that into hours? Divide by 60. So 10 over 60 or 1 over 6. All right, so then to get our distance, we know we just multiply rate times time. So now we have to decide. The mixture problems, it's the same every time. You add the first two to equal the total. With the distance problems, we have to think. Sometimes we're adding, sometimes we're subtracting, sometimes they're equal. What's going to be true on this one? Well, they start at the same spot, right? They both start at his house. They're going the same direction, and what do we want to happen? Yeah, if they're going to catch up and they went the same path, they're going to be equal. So kind of like if you go somewhere and come back, or two people are catching up with one another. Those are the cases where it'd be equal. So now we distribute. Okay. The question wants to know the time. So x is in hours, right? This means it's been half an hour. X is how long Mary has been riding. So Mary's been riding half an hour, or 30 minutes. If she left at 2:10 and rode for 30 minutes, how long has she, or what time is it now? Okay. Do we have a question? Did I make a mistake or something?
too.
Oh.
Because
Yeah.
there's 60 minutes. So you're dividing it by the 4 because there's the x with the 4, so it's 2 divided by 4.
But if you convert this into a fraction, it's just, I kept it as a fraction, so I knew exact answer, I didn't have rounding issues. Anything else? Let's try another one. Joanne took 20 minutes to drive her boat upstream to water ski at her favorite spot. Coming back later in the day at the same boat speed took her 15 minutes. If the current in that part of the river is 5 kilometers per hour, what was her boat speed? Where do we begin? Okay. What's the formula across the top? What would my labels be on my rows?
First time and second.
First and second would work. You could say there and back if you wanted. Okay. So we know it took 20 minutes on the way there, 15 minutes on the way back. And the current is 5 kilometers per hour. So can you tell me what units my time has to be in on this problem? It has to be hours because it has to match the rate. Since this is kilometers per hour, our time would have to be in hours. So how would you convert 20 minutes into hours? 20 divided by 60. Don't use a decimal, just 0.3 repeating. Let's just go ahead and stick with the fraction, so 1/3. So it'll take 1/3 of an hour. Okay, coming back is 15 minutes, so that would be what? 1/4. Okay, but the only thing I know is the speed of the river. And I know she went somewhere and came back and her times are different. And it said she was going at the same boat speed. How is that possible if your boat is going the same speed?
Because when she was going upstream, the current of the river was going against her, and when she was going downstream, this current was helping her go faster.
Exactly. So if you set your speed when we were going upriver, you notice it took us longer. That's because the water was pushing us back, right? So it slowed us down. So do we know how fast she was trying to go? No. Let's call that x. But the river slowed us down by 5. So what speed did we end up going? X minus 5. But now when we turn around and come back, the river is pushing us forward. So we end up going faster. So we're again trying to go x, but we end up going faster than that. So it would be x plus 5. Alright, so I can multiply my distances. Alright. If you go somewhere and come back, what's true about your distances? They are equal. As I'm solving this problem, try to avoid switching into decimals because it doesn't work out nicely and we want to keep our numbers exact. So if I subtract over my 1/4 of this. questions there? So my sentence, I want to know her boat speed. And that was what x represented here. So the boat speed was 35 kilometers per hour. So we've talked about all these different types of problems. I want to take a couple minutes and try a couple practice ones. So if you look on the back page of this, I just have 5 additional problems. We may not do them all. I just want you guys to try a couple. So I would like if you tried number 1 and 3 for now. Okay, so I'm going to give you a few minutes before we talk. Try problem number 1 and problem number 3 to review some of the old ones that we've done. It tells us we have a rectangular yard. So what do we do first? Draw a rectangle. A length 4 less than 3 times the width. Okay, for this to count as defining your variable, which remember those are your easy points, you have to do it. You can't just draw a rectangle and not write anything down. We don't know the width, so let's call that, I saw a lot of W's. You can use X if you like, but 4 less than, what does that mean? We're subtracting 4, 3 times the width, so 3W or 3X minus 4. Here's the second time I saw a mistake. So first of all, make sure those sides are labeled in your triangle. Then or in your rectangle. It talks about the perimeter. And I saw a lot of people that just wrote this. And what's wrong with that? We have 4 sides. We have 2 of these and 2 of these. Okay, so 6W minus 8 plus 2W equals 48. So add over our 8 and divide. And W is 7. And then what do we have to do?
Plug it back in.
We want both the length and the width. So if this side is 7, 3 times 7 is 21, minus 4 is 17. So the rectangle is 7 feet by 17 feet. Questions on that one? Okay. And number 3, one of the mixture ones. What formula goes across the top for these? Okay. So when I'm doing my labels, you can call them first, second, and total. You can do your percents. We are mixing a 22% with a 2% to get a 4% or a total. So you can label whatever you want, but you do need labels there so I know what you're talking about. So it starts out, how many gallons of a cream that's 22%? I don't know, so that's X. 22%, so the concentration would be 0.22. Must be mixed with milk that is 2% butter fat, so 2% would be 0.02. You always move your decimal back 2 places. To get 20 gallons, so our total is 20 gallons, and that one is 4%. Alright, this is where we had trouble. We did one of these in class, but it was yesterday. Let's think about it. If I need 20, if I had 7 in the first one, how many would I have to add of the second one? 13. How did you get that? So it's our total minus the amount we already have. So then if we multiply, and when you do your 0.04 times 20, what do you get?
Oh, sorry.
Are we okay to this point? Alright. I need a decimal there, don't I? Okay, so now what do we do?
Add the top two and then set it equal to 20.
Add, equal our total. Okay. So if I multiply 0.02 times 20, 0.4, divide, and we get x equal to. So then the question was, how many gallons of the cream that's 22%? So if I look, my 22% was my x. So there must be 2 gallons of cream. All right. What questions do you guys have for me? All right, tomorrow we are turning in homework. All these book problems that we have been doing are due tomorrow. So you guys already have quite a few of them. By quite a few, I mean like, what, 5? Something like that. I don't know exactly if this is page 97 or 98, the last few problems. So add those 3 to your list, and this is all due